topic is 2 wattmeter method. So first we discuss introduction, then measurement of 3-phase power, then 2 wattmeter method, then the phasor diagram of 3-phase star connected circuit, and lastly the variation of 2 wattmeter reading with change in the power factor. So introduction, a wattmeter is essentially an inherent combination of a meter and a voltmeter. Therefore, consists of two coils known as current coil and pressure coil. Basic wattmeter connection has been shown in this slide. And another topic, next topic, measurement of three-phase power. The potential coil and the current coil is so arranged that the deflection is proportional to Vi cos theta. The three-phase power can be determined by the single-phase wattmeter having current coil in each line, and the potential coil is connected across the line at any common junction point. The 2 wattmeter method. In this slide, we discuss how to measure the three-phase power by 2 wattmeter. In general, n-phase power can be measured by mean of n-1 wattmeter. This method is valid for balanced and unbalanced circuit with either the load or the source unbalanced. The three-phase power can be measured by the two mean of two single wattmeter having common potential junction on any of the three lines in which there is no current coil. This is known as the 2 wattmeter method of measuring the three-phase power. The 2 wattmeter power measurement. In this slide, a common diagram of a balanced three-phase load is measured by the 2 wattmeter method has been shown. Here the two current coil is placed in the phase A and phase C, and the two potential coil common node will be placed at node B, and the equation has been derived as follows. P1 equals to the reading of wattmeter 1 will be AB multiplied with IA into cos theta 1, and the reading of wattmeter 2 will be P2 equals to VCB multiplied with IC cos theta 2. Here theta 1 equals to theta A plus 30 degree and theta 2 equals to theta A minus 30 degree. Theta A is angle between the phase current and the phase voltage of phase A. And the basic mathematical equation has been derived in this slide, and we get the result as follows. P equals to P1 plus P2 equals to root 3 VLIL cos theta. To determine the power factor, we also derive few equations as follow. P1 plus P2 divided by P1 minus P2 equals to minus root 3 divided by tan theta, and tan theta equals to root 3 multiplied with P1 minus P2 divided by P1 plus P2, and theta equals to tan inverse root 3 multiplied with P1 minus P2 divided by P1 plus P2. And the basic phasor diagram of the three-phase star connected circuit has shown in this slide, and the equation of wattmeter reading has derived here, and the equation will be as follow: root 3 Vp Ip cos theta plus phi 30 degree plus phi, and second equation will be the root 3 Vp Ip cos 30 degree minus phi. And the variation of 2 wattmeter reading with the change in power factor has been discussed in this slide. Here, if the power factor will be unity, then the wattmeter reading of first will be positive and second will also be positive, and the magnitude of both the wattmeter will be same. If the power factor lie between the 0.5 and 1, then the reading of the both the wattmeter will be positive, and the wattmeter reading of 1 will be greater than the wattmeter reading 2. And the third one, if the power factor will be 0.5, means then the wattmeter 1 reading will be positive, and the wattmeter second reading will be 0, and total power will be wattmeter 1 reading. And if the power factor lie between 0 and 0.5, then wattmeter 1 reading will be positive and other wattmeter reading will be negative. Magnitude of wattmeter first will be greater than the magnitude of wattmeter 2. And if the power factor is 0, then the wattmeter 1 reading will be positive and wattmeter 2 reading will be negative, and the magnitude of both the wattmeter will be equal, and total sum of the total power will be 0.